Hello!
Welcome.
Today we will be exploring fractions, but before we start, I'd like you to think to yourself about some of the things that you already know about fractions.
There are many ways to represent fractions. Here are just a few examples that I can think of. Have a quick think to yourself. Which ones have you seen before? Let's begin by looking at what the numerator and the denominator of a fraction is.
The denominator is a number on the bottom, and it represents the name or size of the parts. So in this case, we know we will be working with fourths. The numerator is the number of parts there are of that name or size. In this example, 1/4 is represented.
Aren't these separate numbers?
The numerator and the denominator are not separate values. Together, they represent the relationship between the parts and the whole.
But what does this mean?
First of all, fractions are still numbers. They are just not whole numbers. We can see this when we look at fractions on a number line. We can see that 1/4 is less than 1 whole, but it is larger than 0. We can also see that 1/4 is more than 0, but less than half. There are different ways in which we can represent fractions too. Firstly, we can use fractions to represent an area. In this example, we can see that 1/4 of the square is turquoise. We can also see that the whole is defined as one square, and we know that there are fourths because the square is divided up into 4 equal parts. We can also represent our fraction as part of a set. Let's look at a set of 16 students in a class. There are 4 boys, therefore 1/4 of the class are boys. Did you notice how the fractions can be applied to many different models? For example, 1/4 of an area, 1/4 of a set, 1/4 on a number line. Notice how different they are, yet they all represent the same number. It is important to remember that the fraction does not tell us anything about the size of the whole. The fraction only tells us the number of parts. In this example, I'm trying to choose which quarter I would prefer of each of these different blocks of chocolate. Let's look at some different fractions on a number line. If there are 4 equal parts from 0 to 1, each part must be called fourths. If there are 3 equal parts from 0 to 1, each part must be called thirds. If there are 8 equal parts from 0 to 1, each part must be called eighths.
Does this mean the larger the denominator, the smaller the fraction?
It does appear that way at the moment. However, remember, we must consider the denominator and the numerator together. For example, let's look at this as if there were 2/4 and 6/8. Notice how we can't just look at the denominator and say the larger the denominator, the smaller the fraction. In fact, in this case, it's the complete opposite.
Okay, does this mean the smaller the numerator, the smaller the fraction?
I can see why you were thinking that. It does appear that way here. However, again, we must always consider both the numerator and the denominator together when looking at fractions. Let's change the fractions again. Now we have 2/3, 2/4, and 4/8. Looking at just the numerator here, you can see that a smaller numerator does not mean a smaller fraction. In this situation, 2/3 are larger than 4/8. Let's recap some key points that you have learned.
The denominator represents the name or size of the parts. For example, fourths or thirds. The numerator is the number of parts there are of that name or size. The numerator and the denominator are not separate values. Together, they represent the relationship between the whole and its parts. And lastly, fractions are numbers too. They are just not whole numbers.